So we're now getting into the new chapter, differential equations. And differential equations are very applicable in real life because the idea of a differential equation is just that you have a function and its derivatives that are part of an equation. So it could be something like y double prime, almost put y squared, y double prime plus 2y prime minus 3y equals 5. So what you see going on here is the function, and then we have its derivatives all kind of mixed together in an equation. And there's certain real life problems or situations that have to do with this. Or you might just know what your rate is. You might know what y prime is. You might know, there's some function and here's its rate. And that's kind of what this assignment's going to be about, is setting that up. So first let's talk about proportions, because these are word problems. These are classic kind of lower level differential equations, like entry level. And they're proportion problems. And what does a proportion mean? If you have, let's just say, two triangles that are proportional to each other, then that just means that, let's just say the side measures here are 1, 2, and 3. Actually, that wouldn't work out. Let's go with 1, 3, and 4. Still doesn't work out. Let's just do 3, 4, 5. It's classic. And we'll just have a bigger triangle. If it looks the same, it has the same shape, it's proportional if it's a multiple of itself. So if, in order to go from here to here, we can multiply itself by something. Let's just say by 2. Then this would be 6, this would be 10, and this would be 8. So that's what makes something proportional, is when it's just some multiple of itself. And that constant could be anything. It could have been, instead of a 2, we could have multiplied all these by 3 instead. That constant could always be changing, and that's the constant of proportionality that I'm talking about. So something that I have here, this isn't really the differential equations, but it just shows direct proportion just means that your output is equal to some constant times a value there. And then inverse proportional is when you have the constant over the value. So if y and x are inversely proportional, that means y equals k over x. Compared over here is direct proportion, means it's k times x. Here it's k divided by x. So that's the difference. That's going to help you out with these word problems. So setting it up, a particle moves along the straight line. Its speed, so that's talking kind of about the derivative, right? The rate is inversely proportional. So you just want to point out that this is the rate. Inversely proportional to the square of the distance s. So the speed is the rate, so it's going to be the first derivative, is going to be equivalent to inversely proportional. So that means we're going to have the constant on the top like we saw up there. Constant is going to be k. And it's going to be the square of the distance. So it's kind of like inversely proportional to itself in a sense, because the rate is going to be equal to the constant over the square of the distance. So what's the square of the distance? The square of the distance, square of s, you can see right here. And the fact that it's inversely proportional is the reason why it's on the bottom. If it didn't say inversely proportional, it just said proportional, it would be k times s squared. I think this is another one very similar. So a puppy gains weight at a rate approximately inversely. So once again, we're talking about the rate. And approximately inversely proportional. So once again, we should be seeing the fraction. We should be seeing that value on the bottom to its age, t months. So the weight gain is w. So its rate is dw dt. And it's inversely proportional. I don't see a square. That's why we had s squared, because it said it right here, the square of the distance. This just says to the age, t months. So if I look here, that's going to be k divided by t. And here's where it would be at. So got to, just be careful with that. See, this one says inversely proportional to the distance s. That's why it's s squared instead of t squared. compared to this one says inversely proportional to its age, and that's why we put the age on the bottom instead of the weight. Okay. The warming or cooling rate of a drink is proportional to the difference between the ambient temperature TA and the current temperature T. So we're going to look at that the difference between these two is TA minus T, right? Difference TA and T. So we're going to be looking for the subtraction. And then it's just proportional. So it's going to be on the top. It's not going to be on the bottom. It's not going to be B or D. So it's just going to be proportional, so that constant times the difference. Now realize it's the rate. So be careful there. They're saying that the rate equals this. And that's what makes it the differential equation. So the rate is equal to that. And last, the learning rate for new skills is proportional to the difference between the maximum potential for learning that skill M and the amount of the skill. So once again, we have another difference problem. I think this is more of a practice problem for you guys. Difference between M and L. And once again, it's the rate. So we're going to be looking for the derivative equal to it. So the derivative is equal to, and it's just regular proportional, not inversely proportional. So it's that one there.